Hello everybody. Alright, so today is probably going to be our last day of covering the dynamic programming topic. Today we're going to be tackling this problem. So this is called the unique paths problem. Given a grid of size nxm and a robot initially staying at the top left position, return the number of unique paths for the robot to reach the bottom right corner of the grid. The robot is allowed to move either down or right at any point in time, so they can't move left or up. Alright, so we're given an example of one, and then the input would be there would be two parameters inputted, and since an nxm array, it's going to be 3 and 2. So basically that means 3 rows, 2 columns, and the output would be 3. From the top left corner, there are a total of 3 ways to reach the bottom right corner: right, down, 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 right, down, right, down. And this is a little bit hard to visualize in your head, so I think as usual we are going to switch over to the whiteboard. So I drew this little robot thing over here, and if we could take a look, essentially what the problem is saying is that starting from the top left corner where the robot is right here, we get to move in 3 different paths. We get to move either right, down, down, and then reaches the goal, or we can move down, down, right. I'll keep this like this, or you can move like this. Those are the 3 options there to move to the robot to the bottom right hand corner. We could, if you want, we could also do example 2 where there's 4 different columns and 4 rows and 1 column. That would be a little bit harder to explain, but essentially, if I can get my whiteboard out, there the problem would instead probably look something like up, and then the goal is here. So you see how there's 4 rows and only 1 column, just like n is 4, m is 1. So in that case there would only be 1 path to the goal, which would be to go down, down, down. Alright, so now that we got like a very clear understanding of what this problem is specifically asking for, we can go about tackling it. So to start off, what we can first realize is that the robot can only move or can come from the top or left and move down and right. Meaning we already know that we're only going to be calling a recursive type function in 2 directions. So if we have like a matrix, which we can specify, call it like dp or something, we know that it would be something like dpij, and then we know that it can only go dp of I minus 1 of j, and then dp of I and then j minus 1. So this is going to be the core logic, because essentially what we're going to be doing is we're going to be imagining this as a sort of recursive type function. We see that we're traveling through the matrix by iteratively going down, which is the I minus 1. If I indicates the rows and j indicates the columns, we're continuously going down the rows and down the columns, because those are the only 2 directions we can go down. So now that we have this core logic here, we'll save this for later. Let's start writing out the function. So let's say def unique underscore paths, n comma m, since we know those are the two inputs we're going to be taking. And defining the memoization array, we're going to say dp is equal to the matrix. So we'll have every single square start off as being 1. So it's going to be 1 times m for x in range of n. So that means it's going to be creating 1 m times, because they're going not there, since there are m columns, we know that the length of the lists are going to be m, but there's going to be n of them. So that's why we're looping through x in range of n, because we want n lists to be made corresponding to n rows. Alright, so that's the memoization array we initialized. And essentially all we have to do from here, now that we got that key logic earlier, is just loop through the list. So we're starting from 1 to n. This is because obviously we're always starting from the first square anyways, so there's no reason for us to, since the robot is going to be starting at the top left corner. If you guys remember, that is indicated by I being 0 and j being 0. So that's why we don't need to go to n or m. We start by 1 to n and 1 to m. So we're just going to be looping through this, and this is the key logic basically. We're going to be continuously appending. We're going to be calling I of j is equal to I minus 1 of j plus I of j minus 1. So it's continuously checking down the rows, and then it's continuously checking to the right of the columns. And now, once we are done with that, we're just going to be returning dp of n minus 1 and m minus 1. Now this is because, like I mentioned, the robot is already starting at 0, 0, so we know that we don't need to take that into consideration. So all we need to do is return this statement. So now we can test this function out. So using the examples before, let's say print unique paths of 3, 2. And as we previously established in this code over here, if we have 3 rows and 2 columns, there are 3 possible ways for the robot to travel in to get to from the top left to the bottom right corner. So when we run this code, we get the output of 3, as you guys can see there. We can also test this with the second one. Instead of 3, 2, if we do 4, 1, there's only one possible route for the robot to go, and that is why the code returns 1. And we can continue testing this, but ultimately everything should stay the same. So yeah, that was the explanation of how to do the unique paths problem. Hopefully that was a clear explanation, and I also hope that you guys like the drawing that I did. I can show it again. Look at my robot. Oh, well, my whiteboard is done, but in any case, hope you guys liked that. I'll see you guys next time. See ya.